Today, we're investigating a topic that affects us all: pesticides and environmental contaminants. We got interested in just how harmful these substances might be, whether people eating different diets have different levels of exposure, and how we can minimize our risk. What we discovered shocked us. Pesticides are associated with a measurable decrease in people's IQ and possible increase in their risk for cancers, metabolic disease, respiratory disease, and more. And children, even in the womb, are affected by them. Studies have been showing these effects for years, and one of the most major studies is based right here in UC Berkeley. It's called the CHAMACOS study. CHAMACOS means little children in Mexican Spanish. This study has been running for over 25 years, tracking the effects of pesticides and other environmental exposures on a farm worker community in Salinas Valley in California. The Salinas Valley is often called the salad bowl of the world because it produces almost half the lettuce grown in the US. CHAMACOS, which stands for Center for the Health Assessment of Mothers and Children of Salinas, is a longitudinal birth cohort study. It began in 1999 and has followed over 800 children, the majority of them before they were even born. Researchers enrolled pregnant mothers into the study and then followed their children over time. CHAMACOS' data appears in over 200 scientific studies. These studies draw from an incredible amount of data collected, about 350,000 biological samples, neurodevelopmental and physical assessments, and even information on diet and school performance. The samples include blood, breast milk, saliva, urine, and even teeth, and even household dust and household air to measure spores and pollen. California requires farmers to report pesticide use by geotagging it, so researchers can even study the effect of living in proximity to pesticides. You might think CHAMACOS only matters for farm workers, but actually, the levels of pesticides measured in this community are similar to what's found in the general US population, leading researchers to believe that the main exposure to these chemicals is through food. The findings from CHAMACOS have been instrumental in shaping policies, raising awareness about pesticide risks, and improving methods to reduce pesticide exposure. We interviewed Dr. Brenda Eskenazi, the study director. At Berkeley, she's the director of the Center for Environmental Research and Children's Health. She's also a professor emeritus of maternal and child health and epidemiology. You study environmental contaminants, specifically in the farm worker community in Salinas. Why should people who aren't in that community care about their exposure to these chemicals?
Well, we don't just study agricultural chemicals. We study all kinds of chemicals, and not just in Salinas. We study and been involved in studies around the world. We have a big study that I've turned over to a former student of mine in South Africa. I've worked on studies on every continent in the world except Micronesia and Antarctica. So CHAMACOS, however, is near and dear to my heart because we are an agricultural state. We are the leading agricultural state in the nation. And when I started the study in 1998, we knew virtually nothing about the effect or potential effect of environmental chemicals, especially agricultural chemicals, on children's health. So I sought to do a study on the potential effects of environmental, particularly agricultural chemicals, on children's health in the Salinas Valley, being an agricultural state.
But even the people who aren't working on these fields are exposed to these chemicals, correct?
We are exposed to these chemicals by virtue of what we eat. So yes, I chose to work with the farm worker families because I thought they would be likely more heavily exposed. What I found is that the mothers during pregnancy did have higher levels of exposure to certain chemicals, organophosphates, which is a certain type of pesticide, during their pregnancy than the general U.S. population of women of reproductive age.
The CHAMACOS study has generated hundreds of papers over time and led to findings in fields from air pollution to genetics to even dentistry. Can you explain more about those?
Well, we have stored about 400,000 biological samples from these families, from the mothers and children. And because of that, it allows us to go back in time and look at many different chemicals as well as other factors. I'm heavy into looking at social factors as well as nutritional factors and physical activity factors, because when you're looking at health of children and health of adults, you really need to look at it in a multifactorial way. And so we try to collect enormous amounts of data and biological samples so that we can go back, when new research questions come up, we can go back in time and explore those questions in data that we've already collected and will collect in the future.
That's really cool. And this bank of over 400,000 samples, how long will that last us?
The way we've stored it, it will last forever if we can find a place to keep them.
Forever and ever? Oh, that's great.
I mean, they're stored at minus 80, so they're stored in deep freezers. But the question is, who's going to pay for that storage? It's actually quite costly. And over time, as the generations of faculty and students age, there needs to be like a repository to keep those samples safe.
Can you talk more about your current sources of funding and what is needed to secure keeping those samples safe and continue to be able to store them?
Right now, we're mostly funded on National Institutes of Health, specifically National Institute of Environmental Health Sciences, National Institute of Aging, and a few other institutes. But that's where most of our money over the years has come from. In a way, we've chosen it to be that way because we want to be impartial. And so we don't want to receive money from sources that demand that we do research in a certain way, except good science.
Yeah.
That is the one requirement we do live up to. So we live on 5-year grants. So each grant lasts for 5 years. When that grant runs out, we go to the next grant and go to the next grant. But what we really need is something that we know will keep these samples alive even when those 5-year grants run out, because sometimes you don't have that next grant funded yet. And that's where the scary part comes. We really need like a donor that says this is important to keep for future generations of science. It will be used for future generations of science. I can give you a case in point. There are 2 famous studies in my field. One is right here, and that's the Child Health and Development Studies. It was started in the 1950s, and they recruited 20,000 pregnant women. Along the way, they collected serum samples on all of these children, women, pregnant women, and over the years, they have followed these women and children, and now the 3rd generation are being followed. Early in the time, they collected about 20,000 placentas. They realized they needed huge amounts of freezers to save 20,000 placentas because they collected the whole placenta.
It's big, yeah.
And it was a lot of freezer space. And at one point, there was nobody to fund keeping those placentas. And they threw out 20,000 placentas because they had no way of preserving it, no funding to preserve it. We look back at this as a tragedy in science because now we can do so much more data collection, genetics, epigenetics, all sorts of molecular biology on just a little piece of that placenta, but none of it was saved. So that's what I mean. You need to have some stable source of funding to keep these biorepositories going, and also to keep the research studies that are longitudinal alive, because longitudinal data collection takes a long time, and the preserving of the data is not something you just put on a computer and it just stays there, because people need to use it. So you need to have people that maintain those data, that create the data sets, that make sure the quality control is there. It's all very costly, and it's not 5-year grants, one after another, that preserves it. That's what we're concerned about, especially as I age. It's aging too.
The thing is, you had retired, you said, back in 2019, right? But you're still working on the study.
Yes, because I care deeply about this community and about farm worker health and about children. We are hoping to really work most closely with our clinics down there that have been really amazing in what they have done. I can just spend a moment telling you about the clinics. The clinic was started by Dr. Max Cuevas. He was a farm worker child. His parents were Mexican born. He was born in the United States, but he picked apricots in the valley and prunes and things like that. And he decided that when he grew up, he was going to serve his community. And long story short, he wound up going to UCSF for medical school and became an OBGYN. And he decided to go back to the Salinas Valley and start community clinics for farm workers so that no farm worker needed to walk more than 15 minutes to get medical care, and that they could be served by people that understood them. And so he set up this chain of clinics that I have been lucky to work with for the last 25 years. We have a very close collaboration, and we now are hoping to establish an institute of rural health to preserve everything that we started to serve the farm worker community. It really became clear during COVID how important our collaboration was, and how important our collaboration was not only with the CBOs, the community-based organizations, but with the growers and the organizations that are serving the growers, as well as the advocates and the legal organizations. So we need to bring those people together as we did during COVID. I helped to co-lead a group that brought together about 150 leaders of the community to serve the farm workers and the agricultural people to make sure that COVID did not destroy the farm worker population and hence destroy agriculture in California.
Right.
By making sure that whether they were documented or undocumented, their health was preserved, because it serves us all. We need them for our food, and we need the ag industry to be preserved for the food for the United States. We're all in bed together, so to speak. Mm-hmm. We all need to work together to make sure that we keep this industry alive, and that means keeping our farm workers in this country and healthy.
Exactly. I've heard you say at the end of one of your talks that our farm workers' health is our health. It affects all of us.
It affects all of us, and it affects the ag industry. It affects the economy of this state. If we don't have fruits and vegetables, we're going to be sick. Mm-hmm. Salinas Valley is the salad bowl of the nation. California is a leading agricultural state in the nation. We need to preserve agriculture, and we need to preserve our farm workers, which means that we need to find a path to immigration. We need to find a way for them to be legitimized, because it serves us all.
And the CHAMACOS study, are you currently studying the third generation of people, or wanting to?
We want to. We want to, but it's really hard to do this. When I was starting this research project, I think I should have seen a psychiatrist at that moment, because when someone said to me recently, "You started a longitudinal cohort study of a migrant community," what were you thinking?
Don't you have a PhD in neuropsychology?
Yes, I do. I don't like to admit it, but yes. And I said, well, it was really important to me that we study people that can't readily be studied. Because right now, most of the longitudinal cohort studies in the world are done on very middle class or upper middle class people. You know, the people that are not going to be moving about, the people that are legal, the people that are college educated, that you don't have to worry about literacy, that you don't have to worry about their language being an unwritten language. And we have to worry about all of those things. So it's really imperative that we go outside of our comfort zone and study the people that really are not easy to study. So hopefully we can study the third generation, but that's going to take a lot of effort and dedicated scientific staff, dedicated field workers, dedicated participants to make that happen.
I hope we'll get there.
I hope we get there.
Yeah. That was the first part of our interview with Dr. Brenda Eskenazi. Part 2 is coming right up. In it, we'll dive more into how to reduce pesticide exposure. We'll answer whether vegetarians and vegans have lower exposure to pesticides than omnivores. I'll also share more about CHAMACOS' findings and how the pesticide industry fights to discredit scientists, especially in the US. After her interview, I'll dive more into the effects of pesticides and herbicides, including one of the most common, which turns male frogs into females and is linked to human birth defects. And I'll explain how US industries keep these chemicals in mass use, despite evidence that leads most other countries to ban them. Luckily, the more we learn, the more we can protect ourselves. I'd love to learn, what are the latest findings from this study, like from this year?
In terms of pesticides, what we're mostly studying this year is on glyphosate. We're very concerned about glyphosate. Up until now, glyphosate has mostly been studied in terms of cancer. And there were questions about whether it's a carcinogen or not. Some countries say it is and should be restricted because of that. Some countries say it's not. And so we're in a place of flux. What we decided to study was actually metabolic disease and liver disease because we saw such an increase in metabolic disease in our population and of liver disease. We didn't know if it's the food that people ate or what was in the food that people ate. In other words, the chemicals that were in the food. So we decided to study glyphosate. And the way we got to it is a clinician in the Salinas Valley, Charles Limbaugh, said to us, I am seeing a rash of liver disease in young people in my clinic in Salinas, and I need to understand it. Could it be glyphosate? Because there had been a study, a small study by a professor at UCSD, Paul Mills, that showed in people with actual profound liver disease that they had higher glyphosate levels. And so we came to Paul and said, Paul, I need to study this in younger people because I'm seeing it in the clinic. And Paul came to us, and before you know it, Paul found a very small amount of money, and we pulled out those biological samples that we had stored all those years, had them analyzed for glyphosate. At a time that we did the study, there was no way to measure glyphosate in human urine. And so because we had the stored samples, case in point, we were able to do a study that got published in the leading environmental journal. And now we have a number of grants in to look at that in greater depth.
Incredible.
There are some really good molecular studies that give credibility to our findings, but we need to really study it in a larger population and look at potential mechanisms in this larger population, like oxidative stress, endocrine disruption of glyphosate. And so we're heavily engaged in writing grants right now to do exactly that. So that's been a major focus of this year. We're also looking at this year the relationship to all of those exposures that we had found early on, organophosphates, exposure, and respiratory illness in the children at age 7. We now have a large study which has been led by Bob Gunier in our group to look at respiratory disease in the children as now they're adults. So they're now between 23 and 25 years of age, and so we're now studying their respiratory health based on exposure to organophosphates early on. We're also decided to focus on the mothers for the first time. The mothers are now middle-aged, and again, there are very few studies of Latinas and how they age and their increased risk for dementias. There are some studies that suggest that African American women and Latinas are higher risk of dementia. And so now we are studying those women and looking at dementia risk factors. We're doing MRIs on their brains and looking to see how they perform so that we can follow them longitudinally and see if they're at higher risk and what increases their risk. Are the pesticides that they're exposed to? Does that increase their risk? They've been exposed to, for example, high levels of not just currently used pesticides, but even pesticides like DDT. Because DDT was used in Mexico until 2000, and it's still in our soil. So we see almost every woman in our study has levels of exposure to DDT and also of its metabolite, DDE. So we can look at, does this increase their risk of dementia? There have been, again, very recent, 2022, excellent molecular biological studies, in vitro studies, animal studies that have suggested that DDT may lead to higher rates of memory loss. This was in rats and in vitro studies. So now we're looking at it in human studies. So these are the things we're actively working on right now. Our findings keep coming out. I typically publish more than 20 papers every year on CHAMACOS. It's an active, thriving cohort, and we need to keep it going.
Absolutely. That's phenomenal, all that you're finding out.
There is one thing I just want to continue to mention.
Yes.
This is really exciting to me. It's led by Andres Cardenas at Stanford and Julie Deardoff here at UC Berkeley. It's a joint effort. Andres used to be at Berkeley and he moved to Stanford, looking at epigenetic aging.
Ooh, do tell.
So they can see that there are certain people whose epigenome age faster than their chronology. And the question is, why does that epigenome age faster than their actual age? We have some evidence that that is related to mortality, right? Not in our study. So what factors create that aging? And we're looking at social factors, and we have evidence that social factors, working in agriculture, seems to age the epigenome. So what is it about working in agriculture? What is it about social adversities that age your epigenome, and how does that relate to morbidity and mortality later on? So this is a very exciting avenue of research that we're involved in right now.
Fabulous. And is something which you've already published papers on so far?
Yes. And all of this, by the way, everything I've just mentioned is funded by NIH. So either the National Institute of Aging or the National Institute of Environmental Health Sciences. So again, all NIH funded.
Amazing. And I know people are going to ask, how do you know that the effects you're seeing on people, for example, increased liver disease, are due to glyphosate specifically, because of so many different exposures? I'm sure as an epidemiologist, you can explain how you tease it out.
We are very careful about the words we use. We don't talk about something being causally related. We talk about it being associated. And to the best of our abilities, we control for everything that we think might explain those findings. So for example, if we're looking at metabolic disease, we're going to control for dietary intake, but we have to be careful about it because the route of exposure might be dietary intake. So we have to think carefully about how to do that. It might be poverty. It might be lack of physical exercise. It might be education. It might be a whole sort of other factors. We have, because our data set is so rich, we have collected information on all of these factors. And we try to statistically control for those things. But we'll never know everything that could be related to metabolic disease or liver disease in advance.
Right.
And that's why it's so important to do a multi-dimensional kind of research. We work with our partners that do animal research, that do in vitro research, and then we try to put together the evidence, the weight of evidence from multiple sources to be able to determine if there really truly is an association. But even then, we're very careful about the words we use because we don't want to mislead the general public to say, we know the cause of metabolic disease. We know glyphosate causes this, when we don't. We only know it's associated with. And we need to keep doing the research to get better and better on that road to causality, but we're never going to be right there unless we do those laboratory-based studies too.
Thank you for the clarification. It's so important, the words we use in the rhetoric, to make sure that the public understands and that we're not overstepping and then looking incredible.
That's right. We need to be credible as scientists, or we're not going to be trusted. It's very important to state, when you find an association, to state that you have found an association. But when you have not found an association, to also state that.
And that actually leads me to something I was going to ask, which is, are there any chemicals or environmental toxicants that you studied that you found have surprisingly little effect on outcomes, or I guess associations to outcomes?
We haven't always found consistent findings. And we have to understand why there's not consistent findings. So if we're looking at, say, organophosphates in relationship with neurodevelopment, we only see associations with in utero exposure. But when we look at childhood exposure and neurodevelopment, we don't see that. So there's an example where we really are very careful, our associations only with very early life exposure. So that's something we keep studying, which is unlike, for example, what we see with respiratory illness. We saw both prenatal and postnatal. So we need to, again, be careful about not just the chemical, but the period of time in life, the critical period, if you would, of when that exposure occurs, to know what's really important and what's not. And also how one gets exposed. So is it in the air, is it in the food? And so we look at these things very carefully and try to tease it all apart. You can see why it's a lifetime of research.
Absolutely.
And why I'm not retired yet.
Yes, absolutely. This is kind of moving on to more about how do we reduce our pesticide exposure and risk. So as you know, the EWG has a dirty dozen list and clean 15. Some people argue that these lists are not very accurate. What would you say about that?
I think EWG works really hard at trying to get this right. I personally use EWG for personal care products, and I personally eat as much as I can organically. But I do that for a number of reasons. Number one, I can afford to. I mean, monetarily, I can afford to. Number two, I want to protect the farm workers, and I know that the more I eat conventional food, the more they get exposed. And number three, I'm concerned about my findings. So I am concerned about my health as I get older and the health of my family. With that said, I am very aware that not everyone can afford to eat organically. I'm also aware of the cost of eating organically and that there may be certain crops that can't be grown completely organically, because I know what it takes to grow crops. Most important thing, eat lots of fruits and vegetables. Everyone should eat lots of fruits and vegetables. It is important for our health, our children's health, our pregnant women's health, our fetus's health, and our health. But wash your fruits and vegetables really well.
Just with water, just do you scrub them?
I can say what you should do. It's not necessarily what I do. But you're supposed to, and I would, even wash the outside of a banana or a melon. You should be washing it with a little soap and water, will be fine. The rest of your fruits and vegetables, run a lot of water on it. Make sure that you wash them well. If it's like something that you can rub it, and make sure you're washing it in a lot of water. Even berries should be, washed in running water. What I hear all too often, and this is something that drives me crazy, is I eat organic, therefore I don't have to wash my fruits and vegetables. You absolutely have to wash your fruits and vegetables, even if you eat organically. And that is because there are other bacteria. There are E. coli, for example, on our fruits and vegetables. So everyone needs to wash their fruits and vegetables well. But if it's conventionally grown, probably even more so. And make sure you eat a lot of them.
Organic, some people say, well, there's that national list of over 150 substances like pesticides that can be used on organic food because they're approved. So that's why some people say, oh, what's the point of buying organic? What would you say to that?
It's true that there are a number of chemicals that are approved to be used organically. In fact, we've actually studied one of them, which is sulfur. It's used for organic and conventionally grown fruits and vegetables. It's one of the most commonly used pesticides, sulfur. And we showed that there was a relationship with lung function in children who were exposed to living near sulfur. So even organic chemicals can have some impact on our health, but it presumably will have less of an impact. It's safer. I choose to use it myself because of what I know about some of the conventional chemicals and the potential health effects on especially people working with them, and potentially on me and my family. I am a proponent to eating as much as you can organically, but again, eating as much as you can fruits and vegetables. Yes. I have to say that over and over again because when our papers first came out on pesticides and different health effects, many people didn't want to eat fruits and vegetables,
right?
Especially pregnant women, and we realized that was a huge mistake. And so we really need to be sure that that message gets out loud and clear.
And then in the field of environmental science and toxicology, they have the term unfortunate substitutes.
Yes.
Can you explain what that is and how you would address that?
I have a slide in one of my presentations called Whack the Mole. You know, you whack down bisphenol A and then you get bisphenol S. And you whack down PBDEs as a flame retardant and you get all sorts of now other kinds of flame retardants. And I think it has to do with our regulatory process and how chemicals are released and how we often identify after the fact that chemicals can be harmful because our science is always lagging behind and we don't know all the proprietary information till we have lawsuits. So it has to do with how we regulate. Maybe we need to rethink that.
Do you know if there's a difference in pesticide exposure between people who don't eat meat, vegetarians and vegans versus omnivores?
We did a study a long time ago, a really interesting study, where we gave children and families organic food for a week, and we gave them a second week of conventional food. And we looked at their urine samples every day on what they were excreting in terms of organophosphate metabolites, so during the organic diet week and during the conventional diet week. One more part that was complicated is we did it with children in Salinas, agricultural area, and kids in Oakland. So we have an agricultural area, an urban area. We have an organic week and a conventional week of both groups. And we showed that the kids that were living in Salinas, whether they ate organic or they ate conventional, during their weeks of organic or conventional, had higher organophosphate metabolites in their urine than the children living in Oakland, whether they ate organic or conventional. And similarly, in both locations, if they ate organic, they had lower levels of these organophosphate metabolites than when they ate conventional. So we saw a relationship with where you live in terms of living in an agricultural community versus an urban community, agricultural having higher levels of potential exposure, and also what you ate. Eating organic had lower levels of metabolites of organophosphates than eating conventional. So both location and diet were both important. And this study was led by Asa Bradman, who's now a professor at UC Merced.
Can you share more about the policy changes that CHAMACOS has led to?
We have done research on many different chemicals. Our research has led to the reevaluations of organophosphates. It's led to the reevaluation of flame retardants. It's led to the reevaluation of bisphenol A and phenols and phthalates. So we've done work on all of these different things. We will be continuing to do work on other kinds of chemicals along the way as they come up. As I said, our latest thing is glyphosate, which is still being used and you can buy it over the counter. At the very least, I would hope that until we have more information, we regulate certain chemicals so that the average consumer can't just buy it over the counter when we have potential concerns about these chemicals, especially when they needn't be bought over the counter.
Before we started this interview, you told us that you thought Chris was a scammer. Can you tell us more about what gave you that perception, and in general, what kind of ways that scientists should behave to enhance their credibility?
Well, when I looked at some of the YouTubes, I saw someone who was extremely dramatic and seemed to be emphasizing his points maybe a little too much. And that made me uncomfortable. And also brought me back to the idea that sometimes people over-dramatize their findings to make a point, and that it affects our credibility. And so it's important for me to be relatively conservative about what I say, and to say things in all earnest, where I say the findings that I make, that I find, the ones I think may be strongly associated versus ones I'm just not sure about, and ones that when I don't find anything, to make sure I tell people that too. But I have to be conservative because I want to be credible.
Yeah.
And I want to be credible with all groups that might be involved in decision making, because it's important that I'm taken as a true scientist. I can have hypotheses, but I need to be open-minded about my findings.
And I respect that a lot because, as we know, on the internet and in a lot of organizations, there are scientists who from very small effect sizes will make giant claims because that gets them attention, notoriety.
Unfortunately, it's those strong positive findings that are dramatized are the ones that get the funding.
Which is frustrating.
Which is frustrating. And what we need is funding to just do the science regardless of what the findings might be.
That's so important. You said you retired in 2019, and what was your goal after retirement initially?
I retired in 2019 because I wanted to spend more time in Monterey County and work with the farm workers and work to protect the families as much as I could, and also work with agriculture. I took a great course in 2018 called Ag Knowledge, and it was actually run by the Growers Shippers Foundation in Monterey County to teach leaders of the community about agriculture. And it opened my eyes to many different aspects of agriculture. And I wanted to really dedicate my life to working with the families and the agricultural industry to help in any way that I could. What happened, unfolded after that was, it was 6 months before COVID. When COVID hit, I wrote an op-ed piece with two of my colleagues, a lawyer and a physician, that said the farm workers are going to be hit hard because we know that they live in crowded conditions. We know that they don't all have health care, and we're really concerned about the farm workers and their health and the industry. And so we need to really all buckle down and get to work and make us all work together. That was the week after the shelter in place, that article came out. And within 2 weeks after that, we started Monterey County Coalition on Agriculture with my colleague at Cal State Monterey Bay. And within 6 months, we had 150 leaders getting onto Zoom calls to try to figure out how to protect the farm workers. We also did an epidemiologic study, and I will say I knew nothing about infectious disease, showing that farm workers had twice the risk of getting COVID, just as we had hypothesized. And as a result, the Latino caucus of the state of California were able to get agricultural workers put into the essential worker category. And when vaccines came out, because of our findings, they were put into the category of medical workers to get vaccinated right off. Even though I thought I was going to be working in a different capacity to help the farm workers, this is how we worked. And we brought together, I spoke earlier about Clínica de Salud de Valle de Salinas and Max Cuevas, and the grower shippers came together and started a program to test and vaccinate the farm workers very early on. And then we established we worked with people at Jennifer Doudna's group here, the Nobel laureate, funded by people in Monterey County, to bring vans around the farm worker community to get farm workers tested for COVID so they wouldn't go back to work sick because they were concerned that they would lose pay because they didn't have benefits. And so we would go back to work sick, and then they would get other people sick, and we were trying to establish a way to get them tested and vaccinated. So there was a lot of effort. It wasn't what I had intended, but I did work very hard during COVID to protect the farm workers. And now I'm back to the environmental sciences, even though COVID's still happening.
Thank you. You're an angel, truly, for devoting your life and your work to helping this community and thereby helping the health of all of us.
I like to think I'm just doing my job, because all we're doing is moving grains of sand to help others, you know.
Let's take a closer look at CHAMACOS' findings. What CHAMACOS has linked pesticide exposure to is alarming, to say the least. First, lower IQs. Every tenfold increase in measures of organophosphates detected during a mother's pregnancy corresponded to a 5.5-point drop in overall IQ scores in children at age 7. Organophosphates are a class of nerve agents used in many pesticides. They're designed to shut down the nervous systems of insects. The CHAMACOS children with the highest levels of prenatal pesticide exposure scored 7 points lower on a standardized measure of intelligence compared with children who had the lowest levels of exposure. This effect on IQ is similar in magnitude to what's caused by lead poisoning. Similar results were found in sister studies done by Columbia and Mount Sinai, which examined urban populations in New York City. Dr. Eskenazi says this IQ drop has a substantial effect on the population-wide level.
So what we see here is that across the board, the mother's levels of organophosphates during pregnancy were associated with decrease in working memory, significant decrease by about a 4 to 5 point decrease in IQ. And to put that in a frame of reference, the standard deviation in IQ is 15 points. So this is about a third of a standard deviation. If you move a whole population of humans down a third of a standard deviation, you are going to have a lot more kids that need special services. You have more kids. So this is a substantial association, I should say.
Second, neurodevelopmental disorders. CHAMACOS showed higher rates of ADHD and autism among children of mothers living in areas with higher rates of the organophosphate acephate. They also found that elevated levels of pesticide exposure in the womb was linked to neurological delays and autism-like symptoms in 2-year-olds. By age 7, the children with the highest exposures showed behavioral problems and IQ loss. By age 14, the link to autism spectrum traits persisted. Dr. Eskenazi has said that these adverse neurological effects are long-lasting, persisting into the teens and beyond. Other research groups have reported similar findings, linking organophosphate pesticide exposure to adverse neurological effects in children. Third, respiratory problems. Children exposed to pesticides, like sulfur, are more likely to develop asthma and other breathing problems. Fourth, hormonal disruption. Pesticides can disrupt hormones in children, affecting the development and even the timing of puberty. One CHAMACOS study showed how phthalates, parabens, and phenols in personal care products that mothers use are disrupting the hormones in their children in the womb, affecting their timing of puberty. Early puberty is linked to an increased risk of cancers and mental illness. Fifth, liver and metabolic issues. Exposure to glyphosate, the most widely used herbicide globally, has been linked to liver inflammation and metabolic syndrome in teens. This means they are more likely to develop liver disease. These conditions can increase the risk of serious health problems later in life, such as liver cancer, cardiovascular disease, and diabetes. The metabolic and liver conditions the researchers found in 18-year-olds living in Salinas farmworker communities were once diseases found mostly in older adults. But the national prevalence of childhood metabolic syndrome and obesity has increased at an alarming rate, especially among populations of color. These could be related to other causes such as poor diet or excess weight. But the association with glyphosate remained when they controlled for these factors. Bruce Blumberg, an expert on obesity and related metabolic disorders at the University of California, Irvine, said that the findings aren't surprising considering other studies showing liver toxicity and microbiome effects in animal models. Let's take a closer look at glyphosate. Glyphosate is the active ingredient in the weed killer Roundup. This chemical is everywhere in our food, water, and even the urine of over 80% of Americans. The levels of glyphosate found in CHAMACOS participants are similar to levels found in the general population, meaning everyone is potentially at risk. Again, this likely means that food is the primary source of exposure for most people. The World Health Organization classified glyphosate as a probable human carcinogen in 2015. California health regulators added glyphosate to the state's list of substances known to cause cancer in 2017. One study has linked glyphosate exposure to a 41% increased risk of non-Hodgkin's lymphoma. Bayer, the chemical and pharmaceutical giant valued at $60 billion, owns glyphosate. It has settled more than 100,000 lawsuits worth billions of dollars without conceding plaintiffs' charges that the companies failed to disclose glyphosate's cancer risks. Dr. Charles Benbrook, an agricultural economist, wrote in a 2019 Environmental Sciences article that the EPA determined glyphosate wasn't a carcinogen because it referred to unpublished regulatory studies commissioned by glyphosate manufacturers. 99% of those studies found no negative effects of glyphosate. In contrast, the WHO cancer experts looked at studies published in public and peer-reviewed journals. These studies were conducted by scientists not working for pesticide manufacturers. 70% found evidence of pesticide harms. In the 1990s, Monsanto, the original biotech company which produced Roundup, had assured U.S. regulators that weeds wouldn't become resistant to glyphosate when it tried to get Roundup approved. 2 years later, scientists documented glyphosate resistance in weeds. So now, farmers have to spray more glyphosate than ever to control weeds. Over 280 million pounds of it are used in the U.S. annually, and the rate of glyphosate use is increasing exponentially. Meanwhile, cancer rates are rising in the US. Let's look at one in particular, colon cancer. Rates of colon cancer in adults under 55 have doubled since the mid-1990s. Rates of colon cancer have also been increasing in younger adults by about 2% each year. Younger adults are also more likely to be diagnosed with advanced end-stage colon cancer. Early onset colorectal cancer is also now the #1 cause of cancer death for people aged 20 to 49 in the US. There are probably many causes for this, and one of them may be pesticides. Studies associate pesticide exposure with many other conditions like Parkinson's disease, Alzheimer's disease, immune system suppression, and infertility in people. And that's just human health. Environmentally, pesticides are associated with harming wildlife, degrading soil, contaminating drinking water, and causing air pollution. The organophosphate chlorpyrifos was banned in California in 2021, thanks in part to CHAMACOS. But researchers found in 2024 that people in California's San Joaquin Valley are still breathing detectable levels of chlorpyrifos and other pesticides. As usual, industry has interfered with science to keep harmful substances from being regulated. Atrazine is a widely used herbicide in the US, primarily on corn. It's banned in the European Union. The agrochemical company Syngenta, which owns atrazine, had asked Dr. Tyrone Hayes at UC Berkeley to study the effects of it on amphibians. Hayes found out that atrazine was an endocrine disruptor. When he reported that to Syngenta, they cut funding for his research and refused to report it. So, to validate his work, Hayes got other funding to replicate his experiments. Hayes' studies, published in Nature and the Proceedings of the National Academy of Sciences, linked atrazine exposure to changing male frogs into functional females. He co-authored a paper showing how atrazine induced prostate and mammary cancer in lab rodents. He also showed how atrazine turned male tadpoles into females with fertility problems. Since then, atrazine has also been linked to birth defects, including in humans. Syngenta got its first class action lawsuit in 2004. A presentation by Syngenta's global product manager said that, quote, "We need atrazine to secure our position in the corn marketplace. Without atrazine, we cannot defend and grow our business in the US." Syngenta's communications manager wrote that at least the attention on atrazine helped distract from other herbicides it made, like paraquat, which had become controversial too for its impact on human health, like possibly causing Parkinson's disease. Syngenta launched a multi-million-dollar campaign to protect atrazine from being regulated by the EPA and invalidate research documenting any harms. They harassed Hayes. They sent people to attend events Hayes spoke at and publicly mock him. In 2012, Syngenta made it so that Googling Dr. Tyrone Hayes led to paid results from groups like AgSense, which criticized Hayes for being unprofessional. A list of ideas Syngenta wrote to discredit him included, quote, set trap to entice him to sue, and, quote, investigate wife. Hayes is just one of the many scientists that Syngenta has attacked. One professor investigating paraquat said that Syngenta representatives even tried to intimidate her students. Syngenta paid scientists to downplay atrazine's effects. They also tried to emphasize the financial benefits of atrazine. A New Yorker article says that Syngenta paid Don Corsi, an economist at the University of Chicago, $500 per hour to study how an atrazine ban would affect the economy. They gave Corsi the data to use, funded his paper, and edited it. No surprise, Don Corsi announced at a National Press Club event in Washington that his paper's takeaway was that, quote, a ban on atrazine at the national level will have a devastating effect upon the U.S. corn economy.
You end up with, at a national level, an atrazine ban producing between $2.3 and $5.0 billion per year in losses. $2.3 to $5.0 billion per year.
About 80 million pounds of atrazine continue to be used today, especially on corn. What Syngenta does to protect atrazine is just like what the tobacco industry did to protect smoking. It's a tale as old as time. Dr. Eskenazi shared some great ways we can reduce pesticide exposure. Here's more. A 2021 study in food and chemical toxicology did find that vegetarians and vegans have lower exposure to pesticides than omnivores. They attribute this to the group's lower consumption of animal products and higher likelihood of choosing organic produce. If choosing animal products, the type matters. Fatty animal products like meat and dairy tend to accumulate more pesticides than leaner options or eggs. And the type of feed given to animals influences pesticide levels. Animals raised on conventionally grown feed have higher pesticide residues. Many studies have corroborated what Dr. Eskenazi said about the dramatic effect of eating more organic produce. A 2022 study in environmental research found that switching to an organic diet for just 1 week led to significant decreases in urinary pesticide levels and improvements in some health markers, including lower blood pressure and cholesterol levels. This suggests that even short-term organic food consumption can have measurable health benefits. Biomonitoring studies done in other countries like France, Germany, Spain, Italy, and the UK all show that people eating more organic food have significantly lower pesticide exposure than those who don't. Anyway, as Dr. Eskenazi says, it's still better to eat fruits and vegetables than to avoid them entirely if they're conventional. By the way, many countries ban more pesticides than the US, including developing countries like Brazil, Thailand, Sri Lanka, and Bhutan. A 2019 study found that the US uses 72 pesticides banned by the European Union. Many pesticides classified as highly hazardous by the WHO are still used in the US. For example, one herbicide used in the US, paraquat, is linked to causing Parkinson's disease and is banned in over 50 other countries. Syngenta is the manufacturer of paraquat. You may recall that they also manufacture atrazine. There's also the fungicide chlorothalonil, classified as a probable human carcinogen by the EPA, which is banned by the EU, but is still used widely in the US on crops like peanuts and potatoes. In countries besides the US, the pesticide regulatory process is much less influenced by industry lobbying. They also take a more precautionary approach to regulation, banning substances with potential harm, even if there's no definitive proof. Meanwhile, in the US, there's a revolving door between regulatory agencies and the pesticide industry, meaning former EPA officials take jobs at pesticide companies and influence their decision-making. Pesticide companies often keep their data private, calling it confidential business information, making it hard for scientists to review. Contributing to the problem, the US regulatory system focuses on short-term economic gain of using pesticides, while downplaying the long-term health and environmental risks. But not all is lost. Positive change starts at the local level. The CHAMACOS team engages with the community. They have given over 1,000 presentations and personally educated more than 30,000 stakeholders and community members. They advise farm workers on how to reduce their family's exposure when they come home, such as wash your hands before eating, shower before hugging your kids, and leave your work clothing outside. The study also empowers young people to get involved, doing research and engaging with the community as well. Some of the original children, study participants since before birth, have become co-researchers. These youth design doormats with messages in Spanish. The message says, "Don't leave pesticides in your home. Wipe your feet and remove your shoes." This helps reduce pesticides getting trapped inside. They gave these to CHAMACOS participants and then expectant mothers or those with young children in the Salinas Valley. The CHAMACOS study continues to gather data and insights. Hopefully, they can enroll a third generation of participants, the children of the original CHAMACOS children, to study the long-term and potentially transgenerational effects of pesticide exposure. Studies like CHAMACOS help protect us, but they're at risk of disappearing due to lack of funding. As Dr. Eskenazi says, we are what we eat. And when we protect farm workers, we protect ourselves. By understanding the risks of pesticides and minimizing our exposure, we can create a healthier world for everyone.